All right, this is part 2 of lesson 9-4. In the previous video, part 1 of 9-4, we talked about composition of transformations, which is just combining more than one transformation. And we specifically talked about glide reflections, which is when you slide or translate a shape, and then after you slide or translate it, you flip it or reflect it over a line of reflection, right? So when you combine those, it's called a glide reflection. Now we're going to talk about when you have two reflections in a row, right? So you flip the shape over once and then you flip it over again, so it's twice reflected now. And the rule is if you're reflecting them over parallel lines, those two reflections over parallel lines is the same thing as a translation. So whether you reflect it twice or you just slide it, it does the same thing to the shape. If you reflect them over intersecting lines, meaning the lines aren't parallel now, they cross each other, then it's the same thing as a rotation. So you can reflect it twice or you can just twist it, right? So if it's reflected over parallel, it's the same thing as a slide or translation. If you reflect it over intersecting lines, it's the same thing as two flips or a rotation. So we're going to go over that. First of all, on the study guide that I attached to the video, they give a horrible example of what this is. I think their end point is correct, but this middle step is not the reflection that was meant to be shown. I think it's an error. So I'm just going to show you what the lesson is. I'm going to zoom in a little bit here. Okay, so for the first one, we have this triangle, and we're going to reflect it over line A. This is a line of reflection. And then after we do that, we're going to reflect it over line B. So it's going to be 1, 2 reflections, okay? So first of all, remember when you have a reflection, you have to have parallel like helper lines, basically. So however far away this point is from this line of reflection, it's got to be the same distance from this guy. And this point should be straight across from this point in a perpendicular line to the line of reflection. If I drew a line 90 degrees from this line of reflection, it should cross through both points. So this point right here is going to reflect here. This point up here is 1, 2, 3 units away from this line of reflection. So it's got to be 1, 2, 3 units away from on this reflection. And this last point here is 1 unit away. It's got to be in line with its reflected point, which also has to be 1 unit away. So now I've got this guy, right? So this is my pre-image, or I can call this A. This is my image, so I'm going to call this A prime. That little apostrophe is prime. I'm going to put little quotes around it. And then when I do it again, I'm going to have A double prime. So I've got my pre-image that I started with. I reflected it once. Now I'm going to reflect this over this line, okay? Same rules apply. So this point right here, I hope I have enough space, has to be 3 units away. So it's got to be 3 units away here in line, in the same line. This point is 1, 2, 3, 4, 5 units away. So another point has to be 5 units away in line here. And this point is 1, 2, 3, 4, 5 units away. So 1, 2, 3, 4, 5 units away here. So I'm going to connect all of those, and I am actually right here at the bottom of my little graph paper. So when I reflect this once, it looks like this, and then I reflect it again, and it looks like this. But if we cut out the middleman, and we just go from this guy up here to this guy down here, all we did was slide it. Right? So a double reflection over parallel lines is the same thing as just sliding your shape. It ends up in the same position. So reflection over parallel lines is the same thing as a translation. Now we're going to do a reflection over intersecting lines. I've used a coordinate plane, but they do not have to intersect at 90 degrees. And I'll show you the rule in just a minute if they don't. We're going to do 4 examples. Okay, so if I wanted to reflect this over the y-axis, and then again over the x-axis, first to reflect it over the y-axis, I know this line's going to be here, and this far point out here needs to be in the same line, right? And it's 1, 2, 3, 4, 5 units away from this line, so it's got to be 1, 2, 3, 4, 5 units away here. So when I connect all that, it's going to look like this. This is a reflection of this guy. This is our A. our pre-image. This is our A prime, our new image. Now I'm going to reflect it over this x-axis, right? So same thing. This whole line here is 1 unit away from my line of reflection. So it's got to be 1 unit away from the line of reflection here. This point is 3 units away from this line. So 1, 2, 3 units away here. So I'm going to connect all of those. And this is my reflection, right? This is A double prime. Now, if you think about it, and we kind of cut out this middleman. I'm going to shade him in. We're going to ignore him. I should have shaded these two in. If we ignore that shaded in guy for a second, and you think about this guy rotating around where my 2 lines intersect, this point of intersection is also my point of rotation, my center of rotation. It's going to rotate around, and it's going to end up in this position, right? If I could cut, I don't have scissors. Okay, I just made this little triangle here, and you're going to see my big fingers in here. But if I actually rotate this around, it's going to rotate this way, and then it's going to rotate this way. It's going to land right there, right? It's the same thing. So reflecting it over intersecting lines is the same thing as a rotation. So one thing you're going to have to calculate when you rotate or when you reflect over intersecting lines is what is the degree of rotation. So here's the rule for the degree of rotation. Whatever this middle angle is in between your pre-image and where you end up at, right? There's intersecting lines. You start here. You're going to reflect and land in one quadrant of the intersecting lines, and then you're going to reflect and land outside of it. Whatever the degree is of this angle measure, you're going to double it, and that's your degree of rotation. So in this case, that's a 90-degree angle, right? This is 90. So this whole rotation from here to here is a 180-degree rotation because it's just double this angle that you pass through. Okay, so if this was a 20-degree angle, the degree of rotation would be 40 degrees. You just double whatever this angle is. I hope that makes sense. All right, so we're going to do a couple examples here down at the bottom. What I just explained to you is the same thing up here. They just messed up their picture, so it got confusing. All right, so I'm going to zoom in here. It says copy and reflect figure P in line A and then line B and describe a single transformation that maps P to P prime. Okay, so this middle step that we're doing isn't really a step. It's like we're working through it, but it's not part of our answer. It's kind of imaginary. In fact, I'm going to draw it in pencil. Okay, so if I first start off with this pentagon and I reflect it over this guy, it's going to look something like this, right? Something close, something like this. So that's my first reflection. Notice that these lines are intersecting, right? So reflecting and reflecting is the same thing as a rotation. That was the rule up top. When you reflect over intersecting lines, it's the same thing as a rotation. When you reflect over parallel lines, it's the same thing as a translation. Okay, so that's going to be part of our answer. All right, so from here to here, when I reflect, it's going to be something like this and this. Oh, it should go up higher there, yeah. Boom, boom, boom. Something like that, right? So this is P, this is P prime. This is where we end up with. This was just a middle step. So when we reflect once and then twice, this is where we end up with. If I had to do it in one step, if I had to do the exact same thing but in one step, remember 2 reflections over intersecting lines is a translation. Translation. And since this is a 90-degree, oh, I'm sorry. God, it's not a translation. Sorry, rotation. And since this is a 90-degree angle right here and we pass through that, we just double this angle and it's a 180-degree rotation. 180-degree rotation, sorry about that. When we cross over parallel lines, that's a translation. I know this, I wasn't thinking. Okay, next one. These are also intersecting lines. So we're going to reflect over line A first, and then after we reflect over line A, we're going to reflect over line B. Okay, so we're going to do our best here reflecting over A. I'm going to do it in pencil. Looks like it goes. This goes further away. It's gonna look something like this. This reflected to this, right? And then when we reflect it over line B, it's obviously crossing over line B, so it's going to cross the same, right? So this bottom part is going to cross. This is going to go here, boom, 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 meet up here. And then the top part's going to come, boom, something like that. It's going to look something like that. So this is P prime. Right? And when we reflect over intersecting lines, we take the angle that's in between the pre-image and the image, and we double it. This is 50 degrees, which means this is 50 degrees. So we double this. 2 times 50 equals 100. So this is a 100-degree rotation. I hope that's making sense. When you reflect twice over intersecting lines, it's the same thing as one rotation. How big of a rotation? We'll take that angle in between where your image is and double it, right? And I know this image overlaps into that angle because we reflected it over B, but this area is where we reflected into and then we reflected out of. So that middle ground area is always what we double. So it's a 100-degree rotation. All right, next one. Now we've got parallel lines, right? So first thing we're going to do is reflect over A, and we're going to get something that looks like sort of like this, right? And then we're going to reflect that over B. So it's about this far away. And it goes about here and about here. You can use something called helper lines, and you can use a straight edge. I'll use this side. And you want to always, whatever your line of reflection is, it has to be perpendicular to that line of reflection, but it lines up where your point should meet. So either I didn't do that straight or I didn't draw my thing straight. Let's say I didn't draw the line straight, right? So this helper line is perpendicular to my lines of reflection, which are parallel. And if this point, this is the image I'm looking at to reflect over this line, if this point is here, it should be right in line with this point here that it's reflected to. Same thing on this side. The helper line should line up if you draw a 90-degree angle. Right? Makes sense? These two should be, they're not perfect, but these helper lines show you where how to keep your vertices in line when you draw a reflection. All right? And then how far out it is. You can use a ruler to measure. I just eyeball it, honestly. I don't go to the trouble of using a ruler. But this is what it's going to look like. And then what did we talk about when you reflect over parallel lines? It's the same thing as a slide. Because if we just ignored this middleman and we just looked at our original and then our image, all we did was slide it down, right? So either 2 reflections over parallel lines or just 1 translation. So we'll say translation, and there's no way to measure it. There's no shortcut like the rotation degree thing. Okay, last one. All right, these are intersecting lines, so we know this is going to be a rotation. This is a little trickier because it's a circle, so we got to eyeball it a little differently. We don't have straight lines, but it's still the same idea. All right, so first we're going to reflect over A. Oh, that's not going to be fun. We're going this way and then this way. So we're going to here's line A. Trying not to pay attention to B. If I ignore B and just look at line A and I reflect over it, this should meet up. So it should be something kind of like that. That's a terrible circle. Hopefully yours is more symmetrical, but it should be something close to that, right? So here's A. Now I've got to reflect over. Oh, I didn't mean to do that in red pen. I meant to do it in pencil. Let's see if I can draw over it in pencil. Darn it. Had the red pen in my hand and wasn't thinking. All right. Then when we reflect over B, it's overlapping again, just like it was overlapping here with A. So when we reflect over B, it's also going to be overlapping. So you've got this overlap here, and you have to draw the rest of your circle. Oh, that was too big. Anyways, we flipped it, and then we flipped it again. So it should look something like this. This should be P prime. I never wrote P prime down here. This should be P prime. This should be P prime. And whenever we reflect over intersecting lines, it is a rotation. How big of a rotation? Well, it tells us here, I wrote over it, but this is a 125-degree angle. Well, this is our center angle here that we kind of flip through. Flip over, it's in the middle of everything. So this is the angle we have to double, right? So how can I figure that out if I know that this big angle is 125? Well, together they add up to a straight line, which is 180. So 180 minus 125 is 45 degrees. So if this is 45 degrees, 55 degrees, sorry, 55. If this is 55 degrees, 70, 80, yeah, then this is vertical, so it has to be 55 as well. And remember, your degree of rotation is double that. So 55 times 2 is 110. So this is a 110-degree rotation. Okay, that was a little confusing, I know, I'm sorry. If you just keep the basic idea up here at the top, it's on your study guide that I attached below the video. Just remember that two reflections, or a composition of two reflections over parallel lines, is the same thing as one translation, or a slide, and two reflections, or the composition of reflections over intersecting lines, is the same thing as a rotation, right, or twisting it around the point of origin, or the point of intersection of the two lines that are reflecting over. Okay, and to figure out the degree of rotation, look at the angle in between your image and your pre-image and double it. That's all you have to do. Let me know if you have questions.